when I'm demoing later, I might need to switch back to my computer. I don't know if that's okay.
Okay.
Yeah. Okay. Are we good?
Yes.
Okay. So hi, my name is Frank Lee. I'm a customer support engineer intern, and this summer I've worked on Unitrans bus projects. So a little bit about me. I go to UC Davis where I study electrical engineering, and I'm going to be an upcoming junior this fall. And I'm from San Jose, California, and I've worked at the customer support engineer department. And last but not least, I have been a bus driver at Unitrans for over 1.5 years. Now, Unitrans is a public transportation system at Davis. It is completely run by UC Davis. And one interesting fact is that all Unitrans drivers, including me, and supervisors are students of UC Davis. They all go through weeks of training to obtain a commercial B license, and they drive around 12 to 13 hours per week. Currently, there are about 50 buses at Unitrans that use CNG, which is compressed natural gas. And most of the buses are manufactured by New Flyer, which is a bus manufacturing company. And by being a Unitrans driver for 1.5 years, I could first-handedly experience flaws and possible improvements to the company. Now, to briefly overview my project, I want to monitor the buses in real time, collect attributes that can help with the maintenance of the buses, such as engine data, fault codes, GPS data, etc. And finally, I'd like to visualize this data to help the maintenance team. Now, to get an idea of my project goals, I made my first visit to Davis, where I met with Andy Wiley, the Unitrans maintenance manager, and asked him what the biggest problem is to the company. And he stated that there were 142 road service calls over 50 bus fleets last year. A road service call is when a bus seems to have a problem, like the fault light is on. The maintenance crew has to drive out to the bus with their own little diagnostic box to check if the problem is severe. Now, each of these road service calls have impacted the riders with disruption of service and were potential for safety incidents resulting from in-route transfers and road hazards. Now, with this in mind, I came up with a potential solution to the problem, which is creating a dashboard with real-time location and attributes of the bus and remotely viewing whether or not the fault light is crucial. Now, however, there were a couple of questions I needed to address before, and they were, what kind of data should I get, and how do I get the data from the bus? And when I get the data, how do I convert it to pi points? And how do I send the data to maintenance shop in real time? And lastly, what do I do with the data? So the first question, what kind of data should I get, was answered during my second visit to Davis. Well, first of all, I knew that I needed to collect the fault code data, so I received a list of fault codes from Andy. Afterwards, I put that list in my personal VM's AF table to be used for table lookup in the future. I also asked Andy what other parameters might be useful to be collected so that he can view it in real time from his office. And he gave me a list of parameters such as engine oil pressure, engine coolant temperature, battery voltage, etc. So the second question was, how do I get the data from the bus? So all buses have a port called J1939, which is similar to the OBD port on cars. This port is used when you bring your car to an auto shop and they want to retrieve data from the vehicle. By data, I mean any type of data from vehicle speed, battery current, to engine oil temperature, engine RPM, and the list goes on. This port actually outputs a long list of zeros and ones continuously, like this, where the green box represents what the parameter is, and the red box represents the actual data. Now, by talking to transportation industry principal of OSIsoft, Matt Miller, I was able to get help from a company called Monaco Monitoring, which they make this device that plugs into the J1939 ports, read this long stream of zeros and ones, translates it into meaningful data, and stores it into Modbus register. Now, Modbus register is a way to store data. Each register holds 16 bits of information, as you can see over here. And as you can see from this picture, you can see how the engine data is allocated among the register. For example, if you wanted to know the engine RPM, you would just need to look at this register, the 400,017, and it'll just keep updating you with the real-time value of the engine RPM. Now, I made my third visit to Davis to test out the Monaco device. Behind the driver's seat, there's a locked cabinet with J1939 port that I was able to use to mount the device. And by using Monaco's own software, I was able to view the live data. As you can see, the data is, you can see the parameters updating in real time. And next question was, when I get the data, how do I convert it to pi points? Because right now I'm just getting Modbus register data. And the answer to that question is by using pi Modbus connector, which looks like this. And it required me to add a configuration file where I specify where in the register the data is. So for example, it was 400,017 for engine RPM, and what type of data type it is. So for my cases, all my data type was in float, as well as scan rate. So 1,000 represents just one scan per second, and as well as attribute name. Now, next question was, how do I send the data to maintenance shop in real time? At this point, the data is just being stored in the Monaco device. I needed a way to send this data online so it can access the Pi server. So what I needed was a router. So with the help of Stuart Young, I was able to get a loaner device from Cisco, a loaner router device. This device is called IR829, is an industrial rugged router designed to withstand heavy-duty environments, which was perfect for the bus. I also had a Pi Modbus connector embedded, meaning Monaco device can connect to this router directly and send the data to the Pi server. Now here's a little snapshot of how to manage that router. The next question was, what do I do with the data? So first, what I did was I used Pi Vision to view the data, and I was also able to get the bus's location via publicly available web API, and with this, I was able to put it through Pi Esri integrator for ArcGIS that converts the latitude and longitude data into a map view like this. And lastly, I combined these two and used Esri's operations dashboard that has a map feature as well as the Pi Vision feature to create a dashboard looking like this. Now I'm going to go over the data flow for my project briefly. So on the top left corner, you can see that solid line represents a physical connection, and the dotted line represents the virtual connection. So as I mentioned earlier, I was able to get the location through a web API from a website called Nextbus, which is a website that a lot of bus companies use to track their buses. And then from there, I was able to run a simple PowerShell script that translates the web API data and puts it into a CSV file, which was perfect to be read by the PyUFL connector that reads the CSV file and translate it into Pi points. Now within the bus, as I mentioned earlier, the J1939 port sends data into the Monaco device, which is also sending the data through the Cisco device. As you can see, they're all physically connected. And from the Cisco device, I had to talk to the Pi Data Archive. However, I needed to connect the relay first, which is a relay server that connects the Pi connector to Pi Data Archive. So I was able to use OSI's demo framework server, where the relay server was hosted. And the purpose of this relay is first to improve security, and also it made it easy for me to bypass OSI Soft's firewall. And both data from the bus and the web API is fed into the same Pi server, which goes into the AS server. And next, this is the visualization part. So the Pi Vision, the Esri integrator, and then they are both combined in the Esri operational dashboard. So this is my entire data flow. So I'm going to quickly change to my computer to show you a quick demo of the. Can you see that?
No, you have to share your computer, I think.
I think I
Yeah, you're
did.
sharing it. Yeah.
Okay, well, I'm just hoping that people can see it.
Yeah, we can see it.
Okay, perfect. And this is my operation dashboard. So on the top side, you can see the map view of the real-time location of a bus, and if you click it, you see the vision widget over here that tells you the speed, the RPM, and the battery voltage, engine coolant temperature, engine oil pressure, and also these fault codes. So what I did, I told the maintenance manager to just trigger a fake fault code, and then it's shown right here, whatever that means, whatever these two means. It's being fed in real time. And this view is what the maintenance crew will view to track their buses. So eventually, if I have more buses, I can click other buses, and then it'll, if I click it, the Pi Vision widget will update to those buses data. Okay, I'm going to go back to my presentation now. Now, in the future, I would like to continue to work on this project with Andy, the Unitrans maintenance manager, and I plan to collect more parameters, and when I have more data, I would like to have more analysis with it, for example, by using Power BI or any other analytic tools. And if Unitrans is impressed with my idea, I would love to implement it in more buses. And by hopefully doing so, I will be able to create a possible partnership with Unitrans, Cisco, Monaco, and OSI Soft. Now, the biggest lesson I learned from this project was interdisciplinary communication, meaning that I was able to communicate with people from different departments as well as different companies. I've talked to almost every department at OSI Soft to get help and support. For example, I talked to numerous CSCs to ask general Pi questions, the IT to lend me a SIM card for the router, and the developers for questions regarding some beta versions of Pi Connector, and solutions architects to get in contact with other companies. And by doing so, I was not only able to get exposure to other departments, but also improve my communication skills. I also learned that my project was similar to an actual CSE job. So when a CSE, or customer support engineer, runs into a problem while working with the customer, he or she has to look for the solution by researching through internal search or talking to other engineers. Similarly, when I had a problem or even an idea, I always look for a correct person to talk to. This made me be more prepared for the problems that an actual CSE will face. And of course, I learned a lot about Pi system, especially the Modbus connector and Esri integrator. Last but not least, I helped find many bugs in Pi system. So I'd like to thank and appreciate some people that helped me with my project. So within OSI Soft, first Matt Miller, who is a transportation industry principal, for just overlooking my project and giving me numerous connections. And Wei Kang and Addison, whenever I had Esri integrated questions, they were able to give me help for it. And John Matringa, since he works closely with the academic program, he was able to guide me to talk to correct people in UC Davis. And Colin and Stefan, who are CSCs, for questions regarding Modbus as well as Pi Connector. And Jason and John, who are also in support for just general Pi questions. And Stuart and Glenn, for who are solution architects at OSI Soft, for giving me connection to Cisco partnership, Cisco, as well as helping me with configuration of the Cisco routers. And John Madam and the IT department for giving me access to the demo framework server. And outside OSI, I'd like to give a huge thanks to Andy Wiley, who is the Unitrans maintenance manager, for letting me mount devices on the bus with no trouble. And Doyle and Adam from Monaco Monitoring, they are they're the CEO and the project manager of Monaco Monitoring for loaning me a device as well as helping me with configuration. And Mohammed, Chandra, Nico, Matt, Pat, and Krishna from Cisco for loading me Cisco device as well as helping me with configuration of Cisco router. And also I'd like to thank Team Dirk, Dirk, my manager, Marwan, my mentor, and Sue, John, Chris, my teammates for making this summer very enjoyable. And also Barry for giving me this great opportunity. And lastly, the San Leandro interns. Thank you. Any questions?
Where did you come up with?
Go ahead.
Where did you come up with the idea for the project, and when did that formulate for you?
Well, coming here, I had another project in mind that I was just working. I mean, I guess I had just had a small idea, but then I just scrapped that. And one of my friends, actually, one of the people from my team, was doing his project on monitoring his own personal vehicle, and that just like made me. I wanted to do a similar thing, but since I'm a bus driver, why not put it in the bus? And from then, my idea just kept.
Great. Hey, this is Stuart, and we're here in San Leandro. We have Esri in the room, so they were able to view this demo, and I want to say really nice job. I think the project overall could have had so many problems along the way, but Frank pursued and persevered to get things done, so great job. Frank, I think you have a future outside of being a bus driver.
Yeah, maybe.
All right, you do for sure. Anyway, very, very nice, and I think we're all very impressed. So thanks for sharing, and you know, excellent, excellent. We look forward to seeing the next couple of buses come online.
Thanks, Stuart.
Yeah, just to echo what Stuart said, essentially Frank did this whole project from the ground up, starting with bare metal. There was no, nothing in place to start with. So to do that in the time frame that you did was quite nice, especially given all the moving parts that you had. So that was quite a bit of determination.
Any other questions on the call?
One quick question regarding Mr. Wiley, the maintenance manager. Curious as to how I know he was very supportive. Has he had a chance to see what you've done yet, or do we still have yet to work with them?
I mean, whenever I made a visit to Davis, Andy was there to help me just mount the stuff. And I actually went up there yesterday, and I was able to give him a quick demo. And he talked to a couple other people at Unitrans, like the assistant general manager and just a couple people from the shop, and they all got to see my project, and they think it's a really cool idea because the just like driving all the way to the bus to see what the problem is can be solved is really a huge like step for them. And also Andy and a couple other people from Unitrans, they attend like a transportation convention every year, a public transportation convention, and Andy was thinking of possibly bringing up this idea in that convention. So I have a lot of support from both, just everywhere.